Here we go, curl and divergence 16.5. Let's get to it, my friends. Okay. So let's see here. Divergence and curl are two characteristics of how flow is behaving on a vector field in a small neighborhood around a given point P. Divergence is a measure of how much fluid or flow enters the neighborhood around P compared to how much leaves. If more fluid or flow enters the neighborhood than leaves, then divergence will be negative at that point. Think of this as fluid or flow gathering at the point. If the same amount of fluid or flow enters as leaves, then the divergence will be zero at the point. That's called incompressible. If more fluid leaves than enters, then the divergence will be positive at that point. Think of the fluid leaving the point or diverging, called divergent. How to find divergence? Remember the operator del when we were finding the gradient? And so they say, well, del could be thought of as the partial with respect to x, partial with respect to y, partial with respect to k. That's a vector. And then you also have this vector. This is our vector field. And so the divergence of f is equal to del dotted with f. And they say that if you looked at that as being dotted, that would become the partial of p with respect to x plus the partial of q with respect to y plus the partial of r with respect to z, and this is a scalar. This is how I like to remember it, not as much as the dot product for me as it just this. And in fact, I have to watch myself all the time because when I'm doing Green's theorem, I want to do this too. I want to do something similar to this, which it's not. Then the other thing, curl, and then we'll do a few examples, is the measurement of the rotation of the vector field in a neighborhood around P. If there was a paddle at the point, the curl measures how much the paddle spins. And so this is a little paddle, and if you had a paddle at that point, and a really tiny paddle, if the curl is the zero vector, because curl is a vector at a point, then there is no rotation at P, and it's called irrotational. And recall the del again is this, and you have your vector field F there. Then the curl at F is del cross F is what they tell us. That's a formula. We'll be looking at we'll be doing a couple examples on calculating it. Remember when you did a cross product? It's been a long time ago, I know, but you could do it as a determinant. And so you put your I, your J, your K, and then these are the pieces of del, the partial of x, partial of y, partial of z, and then these are the pieces of our vector field P, Q, R. This is a vector, and then I just noted, just to remind you, I guess I had told you before, but we didn't know how to find the curl. Note, if the curl of F is the zero vector, then F is a conservative vector field. So just a reminder on that. Don't worry, we're going to do an example on that too. And find the divergence in the curl for the vector field. And I have a really easy vector field just to start off with, just so that we can do a little drawing of it and then just kind of look at a little bit what it's finding. I'm going to try not to use the whole page. I did that in one of the takes. And so because z is missing, is zero, actually also, so k, I guess is what I was meaning, is zero. Also, I is zero, but I'm gonna draw it just as if you were looking down, just real quick. So this is y, this is x. I'm going to go ahead and I'm going to put my x and my y and my vector. I'm going to call it PQ. just so I can draw the vector field just really quick. Just a few things, not a whole bunch, just enough just to kind of see. If x is 1 and y is 0, then our p, because that's our I, so I'm going to write that right here. This is 0, I, and then minus x, j, and I'm not worried about drawing k on here. And so this is always, no matter what, the p is 0. And in this case, because our x is 1, this is negative 1j. So I'm just going to draw here at 1 when our x is 1. And this is, remember, it has the terminal point at 0. And this would be a vector pointing straight down with measurement 1. And in fact, do you guys agree that in this whole column, when x is 1, that every single one of them, no matter what y is, so y could be 3, is going to be 0, negative 1. And so it's going to be, so up here at 3, there's the terminal side, and then the vector is length 1 and pointing straight down 1. And so that's what you get here for every single point. And then if x is 2, then do you guys agree that no matter what y is, that, so y could be 0, then you would get 0, negative 2. So these would be pointing down, so here at here, but length 2 is what it would have. So every single point here would be length 2. And then over here at 3, you would have all of these would be length 3. And if you did negative 1, so just a brief drawing of this vector field, if you did negative for x, doesn't matter what y is, then we would be getting 0, 1, and we would be getting vectors in the negative 1 here that were pointing length 1 and pointing directly straight upward is what we would get in the y direction there. So anyway, so that's kind of the story on that. And then I'm going to get a little point P right here, and I'm going to get a little neighborhood around P, a small little neighborhood around P. I'm kind of blowing the situation up that I have kind of going. And if you're thinking about it, as fluid goes in and out of this little neighborhood, the same amount is going in as is going out. And so that would kind of tell us that our divergence, this is kind of what it could look like if that divergence was equal to, if the divergence was equal to 0. And so I think right here on this one, that's kind of what that would kind of look like. The divergence would be equal to 0. So I'm going to write that right here. Divergence of f is equal to 0. This is kind of our guess. They didn't ask you to draw them in your book. I just wanted to draw them just to kind of, I saw that on another video, and I kind of thought, yeah, that kind of helped me kind of visualize what was happening. Now, if you thought of there as being a little paddle like they showed at that point P, then do you guys agree that that paddle, because on one side the vector length is longer and than on the other side, so that vector, that paddle would be spinning. And so what that just tells me is the curl of f, because they're longer on one side, and so it's gonna, when it hits the paddle, the other side is gonna, won't balance it off, so the paddle is gonna spin. And so because this is not equal, I don't think this is the equal to the vector 0, so that's my guess, because I'm thinking that the paddle is rotating there. So these are my guess, and now we're going to go see the math on it and just see what happens. So the divergence of f, you could memorize it as a dot product if you like, this dot this if you like, but that's not how I have it memorized. This is how I have it memorized. Haha, and I write it wrong. That's how it goes. This is how I have it memorized. You can have it memorized. You do you on how you just be able to find the divergence. Lucky thing is it's not too hard, and so that's the good news. It's not too hard, particularly on this particular example. It's pretty easy. And so this is P, this is Q, and plus I'll put 0K here, and those are all the unit vector. So this is R. And so if I take the partial with respect to x, well, I got 0 there, so this is equal to 0. If I take the partial with respect to y, and what I've got is x there, so this is 0. And if I take the partial with respect to z, well, I got 0 there, so this is 0. So the divergence here is 0, and it's a scalar. And so, and then I'm going to find the curl. So the curl of f. And the curl is the cross product. And I have to admit that I don't write that. I'm at a point where I'm already writing this because I've practiced it a few times. And partials here. And we want z here, that's p. Negative x, that's q. And 0 here, that's k. So this one's pretty nice. It's a pretty easy one. And because of the zeros. So just to get back into it, you put your finger over the I when you're going to find it. And now I'm taking the partial of this with respect to y, which is 0. I'm taking the partial of this with respect to z, and I'm going to subtract that, right? So, so here I'm taking the partial with respect to y of 0, which is 0. And here I'm taking the partial with respect to z, but it's x. So I get 0 there. So this is I. Remember, this is a vector. I'm going to erase that. I'm going to put my finger over j. Remember, the j's are negative, and then you start again. So the partial of x with respect to the partial with respect to x, but I have 0, so this is 0. Have 0 here, so that's 0. J plus, and then here the partial with respect to x, and so we have x there, so that's negative 1. And then minus 0. So that's our k. So so our curl of f is equal to 0I. Oh, that's not an I. Plus 0j minus 1k. And you can also, this is a vector, so you can also write it as 0, 0, negative 1. And we said because we thought that it was going to rotate on our little cheesy picture, that was our guess, that we guessed it would be non-zero. It is not, it isn't the 0 vector, and it wasn't. Let's try another one and see how we do. The book doesn't ask you to draw them, and they give you ones that are too hard to even think about drawing or whatever have you, but I really kind of liked just kind of starting off like that. And so they don't ask you to draw them, and so I'm only drawing them so that I could try to convince you that, hey, you know, this is kind of maybe a little bit what's kind of going on. So in order to have them drawn, I had to be cheesy. This is 0k is what it is over there. And I'm just going to draw it in 2 dimensions as if we were just looking down on it. We did draw this vector field. I don't know if you guys remembered, but it was the vector field where all of the vectors were length 1. And I think I also asked you on the lab to show that that was true, and that they were all radiating out length 1 from the origin. So they all were radiating out length 1 from the origin. So every single vector was radiating out length 1 from the origin. And so I'm just drawing a whole bunch of vectors, and trying to make them look like they're radiating out length 1 from the origin. And so if I put a point P here, and I drew a little tiny neighborhood around P, and if I got some vectors going, I want to get some vectors radiating out around it so that we can kind of think about it. And so here's a vector of length 1. Here's another one. If you stay up late enough, you'll get hungry again, even though you've had dinner. And so I don't recommend doing that too often. And so there I've drawn some vectors of length 1 kind of going into my little neighborhood. And I want you to notice that where they hit here, then we have vectors that are leaving the neighborhood from the origin here. Here, I can draw these in here. And it might be hard to tell from my drawing, and you guys are better drawers than me, but the vectors this is a smaller part of the circle that the vectors are entering. And so like the fluid is entering. And so I think in this case, and we're thinking about the divergence of F, that less fluid, if these vectors represent fluid, is entering that neighborhood than leaving. Less fluid is entering, more is leaving than leaving. More is leaving. I don't know why I put a D. More is leaving, because this is like a third of the circle, and then like 2/3 of the circle they're all length 1 going out. And so let's remind ourselves here, I'm just going back to the front page. If more fluid leaves than enters, the same amount is 0. More fluid enters, we have more leaving, is what I'm thinking from that. And so that says that we're expecting positive. We're expecting this to be positive. Now the curl, and all I can say, the curl's a vector. So all I can say about that is, do I think it's going to rotate, or do I think it's not going to rotate? And so that's what I'm trying to think about. If there was a little paddle at P, and you had all of these vectors coming out from the origin, and they're all length 1, and if I think that they're all going to hit it, do you think it's going to rotate that little paddle? And to me, it seems like they're all coming out. I'm getting my hands underneath here. They're all coming out, and they're all length 1, and from the same amount from each side going. And so I'm thinking that the curl it's going to be irrotational. I don't think it's going to rotate. And so this is, of course, remember, this is my guess. And now we're going to do the math and go figure out what it is. Now, they don't ask you to make a little picture like this, and they give you ones that are in 3 dimensions. It would be too hard to draw if you didn't have K being 0. But just to kind of give an idea of kind of what's happening, I kind of like that. So the divergence of F, and the formula that I'm liking to use is this. And so I know that it's the dot product, and I have to admit that I just naturally start writing this when I'm, I've had a lot of experience with these. I've done 10 of them out of the book. And so this is P, and this is Q, and that is R right there. And I have to take the partial with respect to x. And so I noticed that it's a quotient, so I'm going to have to use the quotient rule. So you do you on the quotient rule. I have to do it this way because it's after midnight. I promise it is. See, it's after midnight. So I'm having to make sure that I don't mess it up, because if I do, this will be take 6 on this video. If this is take 5, I'm not sure how many takes it is. If I said at the beginning how many takes it was at the time, I might have been right or wrong. Maybe I was not admitting how many takes it was. Yeah, probably I wasn't. It's probably better. Okay, so concentrate on taking your derivative here because you're going to mess it up. That's what I should be saying myself. So I'm taking with respect to x. So x squared, y is a constant here. So when I do the chain rule, this is times 2x, and the 2's drop out. Now I have to remind myself that I am doing the quotient rule. So when you do the quotient rule, you multiply u prime times v. So that is the square root of x squared plus y squared minus, and then you do u times v prime. So that's x squared over the square root of x squared plus y squared. And then you divide that by this darn thing squared, which is x squared plus y squared. Okay, I have to do the same thing for y, but so the partial with respect to y. But good news is that it is exactly the same, but instead of having my u be x, my u is y, and instead of, since I'm taking the derivative with respect to y, instead of this being 2x, when I do the chain rule, it'll be 2y. So do you guys agree with me that it would be exactly the same, except for right here, it would be minus y squared, because u would be a y and that would be a y. And so for the people who are like, what? I'm going to write it. And for the people who are like, no, we had it. You didn't need to write it. We got it. I'm going to apologize to you for writing it. So this is going to be quotient rule. So it's going to be this. Then the next piece is 0. So if I take the partial of it, I get 0. So I'm working on my divergence. I notice right now that they have a common denominator. Do you guys notice that they also have a common denominator? And so that's quite lovely. Now I could add those together if you thought that would be the best way of going. And so is that, do you think, the best way of going since they have a common denominator? I don't know if it is or not. It's half dozen each to the other. But if you did add them together, you would have 2 of those. And then these have common denominator as well. So it would be minus, you know what? I'm going to have, these are both minus. And when I put that up in the numerator, that's going to be x squared plus y squared. Oh, no. I forgot to write his thing. I got to do that next. When did he say it was due? December, I think. Okay, write recommendation. I gotta write that down. Oh my goodness. I was gonna do that the other day and then I forgot. Okay, so this minus here, I'm gonna put parentheses there so that I don't mess up that minus, because I feel it coming on. Because right now, I'm going to be messing up stuff if I'm not careful. So I get that. I'm about to multiply to clear the fraction. I hate that complex fraction thing. It's not simplified. So when I do multiply to clear the fraction, I'll be multiplying by this in the numerator and the denominator, the square root of x squared plus y squared. because I've done this problem a dozen times at this point, I'm going to tell you that it's better not to multiply the denominator together, and you'll just have to trust me. I'm going to try not to take too much more room here, or I'm not going to be able to find my curl. And so when I multiply these together, I get two of those, 2 times x squared plus y squared here. And then when I multiply it here, the square roots cancel out, and I get minus, and I'm going to write it as 1x squared plus y squared. Forgive me for doing that, but I'm going to do that. And so right there, 2 take away 1 is 1, x squared plus y squared. Is that okay if I do it like that? Is everyone okay with that? They're the same. So this is 1 x squared plus y squared over x squared plus y squared times the square root of x squared plus y squared. And then the x squared plus y squareds cancel out. The whole thing cancels out, right? And gives me 1 over the square root of x squared plus y squared. And so this is my divergence of f. And what I had guessed was, remember this was a guess, is that it would be positive. And you can see that for all values of x and y, this is a positive value. And so pretty good guess on that. I don't get that lucky that often. The curl of f is equal to, and you could write it as a cross product, but I have to tell you I'm so over it. I'm already saying to myself, I know it's a cross product. I, j, k, and then do my little these. And then I have these. And I'm going to need room for it too, so I wish I wouldn't have taken so much room on the other. So when I do this, so this is 0. This is the partial with respect to z, which there aren't any of those, so that's 0, and I'm going to write that really small. So 0 minus 0i. Then I'm going to move on to do minus, and then for my j, partial of x, that's 0, partial of z, but there are no z's there, so this is 0 minus 0, and I started thinking, well, maybe I'm not right, because those were both 0. But here's where you don't get 0, or maybe you do get 0. Oh, I guessed it was 0, so maybe I'm thinking I will get 0. Remember, my guess was that it would be 0. So right now, I was thinking, oh, I'm happy, is what I was thinking, and now I'm not so happy. So now, when I go to do this, I have to take the partial with respect to x of this, and unfortunately, I haven't already taken that, and I haven't found that, and so that's a y there in the numerator, and it's not a very good y, and so you could use the you could either write, because y, with respect to x, y is a constant. So you could make it all a numerator. So it's essentially just the same as having 1 in the numerator there, because I'm taking the partial. So if you wanted to rewrite that, so this is what I'm trying to take the partial of, and you could rewrite this y times, and then x squared plus y squared to the negative 1/2, like that, if you liked, so that the y would hold still. Maybe I will just write that right here, because that'll be nice. That's nicer than the other 10 times I did it. And so the y is a constant, so the 1/2 would come down, negative 1/2 would come down in front when I take the derivative, x squared plus y squared times the chain rule. Remember, I'm taking the derivative with respect to x, so this is 2x minus 3 halves there, sorry. because remember, when you take the derivative, you move it down in front and then you take away 1, so that would be minus 3 halves. I don't know why I forgot that, but I'm going to erase it and make it look nicer. You're like, no, don't make it look nicer. And so this is times 2x. So when the dust clears here, the negative half times the 2 gives me negative 1. So this gives me negative 1 x, y, and then x squared plus y squared to the negative 3 halves. So that's the first, I'm out of room here. That's the first part that's going here, is what that is right there, finger over k. And so that's this, negative 1 x, y, x squared plus y squared to the negative 3 halves, minus, and then we're gonna do it again. We're gonna go this way, and I'm gonna do that same trick. So here, dy, and I'm gonna write the x here, and then I'm gonna have x squared plus y squared to the negative half. And if you're a person that's like, okay, I think I can do that because we just did that, and so we're taking the partial with respect to y instead of x, but x is a constant here, and how is that going to look? Well, this is going to be, that constant is going to hold still, the negative half is going to come down in front, x squared plus y squared to the negative 3 halves, and then times, and then it's going to be 2y, right, on our chain rule. So that this is going to give us negative of, this is negative 1, right? So this is negative 1 x, y, x squared plus y squared to the negative 3 halves. And so here, negative 1 x, y, x squared plus y squared to the negative 3 halves. And that makes a plus of that. So this is exactly the same as this. This is k. And so that's 0 as well. So this, for our curl, is 0i plus 0j plus 0k. So our curl is 0. And what that means is that that it's irrotational, and I don't know if I can spell that 2 times in a row. It also means that it's a conservative vector field. And so, but they weren't asking that here, but that's another thing that it means. Okay, that's what they are asking here. So they're asking, hey, is this determine whether or not the vector field is conservative? And so that means that you want to find the curl, because it's three-dimensional here, curl of f. And so this is I, J, K. So you can do write the cross product if you want to write the cross product. I have gotten where I've, this is kind of how I have it memorized, is this procedure. And so this is x, y, z 4, and x squared z 4, and 4x squared y z 3. And so when I do the partial with respect to y, well, there is a y here, so all of this other stuff is a constant, and so 4x squared z cubed is a constant, and the derivative of y is 1, and so that's good, minus. And then here with respect to z, so x squared is a constant, and so the 4 on the z would come down in front, right? So x squared, so this is going to be 4x squared, because x squared is a constant, and the 4 comes down in front, z to the third. And so you can see that, oh, that part's 0. Now, all 3 parts have to be 0 for it to be conservative. So we'll move on to the next part. So minus, and then on the partial with respect to x. So that's going to be all of this y and the z cubed are all constants. The 4 is a constant. So that's going to be 8xyz cubed minus, and then the partial with respect to z, xy is a constant, so the 4 would come down in front. So this 4xyz cubed, that's j. And we can see that that's not 0. So since that's not 0, this is not a conservative vector field. So we can already say that here. That's what they asked us, not conservative. Because all pieces would have to be 0. The I, the j, and the k. If they were asking you to find curl, then we haven't found curl yet. And I'm just going to go ahead and find the curl. And then I already answered the question, not conservative, just for the practice of finding the curl. We're almost done, and I've run out of room. And so plus, and then for the k, so finger over the k. So this is the partial with respect to x. So that's 2x z fourth minus, and then minus with the y going here. So that's x z4. So that's k. So if they had asked me to find the curl, like they did on other problems in the book, we'd have 0i. We would have minus 4xyz cubed j. And we would have plus xz to the 4th k. And that would be the curl. Of course, when you look in the back of the book, they won't write the 0i. And so here, though, when you look in the back of the book, they're going to just say not conservative is what they're going to say, because that's what they were asking about. Okay, that's very good. I'm tired. I'm done. Okay, are you done? What time is it? It's late. Go to bed.